Hello, everybody, and welcome to the QA Financial Digital Forum. So we're live with you today with a really great agenda of speakers, and I'll introduce our first speaker in just a minute, and Nadein from JPMorgan. But first of all, just a little bit of housekeeping. My name's Matthew Crabb. I'm the CEO of QA Media. This event is really designed to focus on all that's new in QA and testing at financial firms in terms of automation and AI technologies. But we have a particular focus for this event today on emerging standards for enterprises, across enterprises, and across marketplaces, financial marketplaces for software quality, driven both by regulators and by firms, increasing scrutiny of standards for software risk, if you like. So we'll be touching on that theme throughout our presentations. To a couple of points of housekeeping, there's a help button to the top right of your screen. We have staff there to help you if you're struggling with anything. When you want to move around between sessions or into our virtual exhibition hall, you click on your timeline towards the top left, and that will take you onto the next session where you have to click, or during the breaks which we have during the day. We encourage you to visit our exhibition hall, our virtual exhibition hall, where you can meet our sponsors and chat to them, organize meetings. I'd like to thank our sponsor partners, because without them, this event really isn't possible. We have Delphix, Keysight, and Eggplant now part of Keysight Technologies, Mabel, Perfecto by Perforce, Perfecto by Perforce, Source Labs, and Tricentis, and you'll be hearing from them through the day with some interesting presentations. We do have a fun competition today, which is you can enter a draw to win an Apple Watch if you visit at least 3 of our sponsors in their booths and collect 3 passwords which they'll give you, or arrange 3 meetings. You can mail those passwords to us at info@qafinancial.com, and we'll have a draw and we'll let you know how you get on. So please take part in that. It's a bit of fun. I don't want to eat into any further into the time for our first speaker. And I'm going to let Anne Nadein introduce herself, her background, and explain her role at JPMorgan more fully. But Anne is an executive director in charge of software engineering at JPMorgan, and she's going to be talking about continuous delivery at JPMorgan, but in particular how the firm is setting those enterprise standards for software risk, and also how it is applying technologies in AI, artificial intelligence, to software development. So Anne, I'm going to hand over to you now, but just finally, on this platform, you can, as delegates, ask questions. We really encourage you to do so. Anne will be leaving some time at the end of her presentation to answer your questions. Please just type them in. You can see the Q&A button to the right of your screen, and I'll be able to read them out to Anne. So Anne, over to you. Please tell us a little bit about yourself.
Thank you, Matt. Hi, everyone. Thanks for joining. My name is Anne Nadein. I am the executive director in JPMorgan, but I also lead and drive the software testing strategy for JPMorgan as the firm. I spent a lot of time, years, delivering applications live. I've learned how to do things, how to not to do things, and I'm trying to apply my knowledge with the set of pretty strong engineers in my team across the firm. Without further ado, let me share the presentation. Just give me a second. I'm going to share. Great. And let's start. I understand the topic is the predictive analytics, so I'll try to focus on it. But I honestly could not cover the predictive analytics or AI in testing without just slightly touching upon the CI/CD process in JPMorgan. Our CI/CD process, well, varies because, frankly speaking, we are dealing with about 40,000 technologists that half of them contributes to the code bases. We run about 100,000 builds a day. We process up to 4 million test results an hour. variety of our languages is impressive, variety of application types and software platforms is also challenging. So all in all, JPMorgan's main challenge is scale. If you look at our pipeline, effectively, they all differ. They can be simpler, they can be more complex, but they all follow a predefined template, which includes 3 standard parts for evaluating the change risk and executing the tests. In general, if I look at the change risk management in the firm, it comprises of 2, I would say, segments, not necessarily separate, more overlapping segments. One is this predefined, well-defined set of rules that we are applying on each software and evaluating each software quality and risk of the software before we release. And second is the actual testing process within the pipeline. Very briefly, if you look at the pipeline, again, we have 3 stages: build, test, and release. And in each one of them, we run some analysis on the software. During the build, even pre-build stages, we're trying to assess whether the application, meaning software, is even eligible for a build and a production release. The software usually has a profile. The profile is created during the first setup or creation of the software. Even before we can cut code, we create the profile of an application. Application profile changes once in a while. Once we have major changes to the software, meaning we change a platform, deployment platform, let's say moving from one cloud to another, or from physical deployment to the cloud, or to a certain grade, or adding a major component, let's say adding a UI component to a backend services. So the application profile is kept pretty much up to date, and the pipeline evaluates whether the profile is set up. Does it contain any potential risks? Does it follow the architectural guidelines that it's supposed to follow? And once that happens, it actually allows the code to be built. In addition to that, the pipeline also verifies that the change that it's about to build actually is wanted, meaning it was requested, meaning there is a issue in our issue tracking system that describes a request for a new feature or improvement or so on. And then finally, there was lately done pretty decent improvement in our pipeline by evaluating the dependencies, the open source usually dependencies of the code bases before we even start building it. Usually it comes down to reading the build files from, let's say, .NET or Java or JavaScript or Python applications, and scanning those dependencies for vulnerabilities, for known vulnerabilities. Once that's done, we proceed to test. And that's where obviously the crux of activity happens. When I say testing, I assume post-unit testing, meaning the unit testing happens during the build phase, and the post-unit, or we call it comprehensive testing, happens once we deploy the software into a target platform and run the comprehensive tests against it. Usually it means running integration tests, end-to-end or acceptance tests, performance tests, resiliency tests against the deployed code. Before doing so, we also run the static code analysis and determine code coverages, the vulnerabilities, the blockers, and so on, meaning the critical items that we need to attend, trying to assess the technical debt that exists in the static application, meaning without really running it. And then in addition to that, we also run additional deeper security checks to verify the actual code base that we own. So in the previous step, we ran the dependencies analysis, and this step we run the actual analysis of the actual code base. All of it sounds interesting, but it's not predictive analytics yet. One step that I missed actually before I jump into predictive analytics is that again, as I mentioned before, the JPMorgan's main challenge is the scale. Our pipeline exists for quite a few years, and with years or with time, we observed that there are many cases, there are many teams that leverage unit tests to run more than just unit tests, meaning, let's say, run integration tests during the build phase because it's possible to do so without deploying the application to the target platform, meaning just instantiating the application within the pipeline and, for instance, validating the communication between the database or communication between messaging system and so on. Those tests are obviously running much longer than the usual unit tests because they had the real resources. In addition to that, these tests have been accumulated and built upon for quite a few years, meaning they are voluminous. Again, with time, we noticed that more and more of softwares are running those tests for quite a long period of time, more than 10 minutes. And if you think about unit testing and think about all the other things that we do in the pipeline, it actually adds on time to the build. It also consumes a lot of compute power, I guess that's how we are coming to process and formulating test results an hour. We had to deal with this problem. And we dealt with it in such a way that we stopped running all the tests all the time, and we introduced built in-house open sourced the algorithm that allows us to run the tests that pertain to the change that we made. The kick of that algorithm is that it doesn't only run the tests for the code that changed, that we physically changed, meaning added, modified, removed lines. It also identifies all the related pieces of the code base that were affected by the physical change that we made, identifies those tests, and pretty much runs all the tests that directly or indirectly test the affected code. We call the tool Sandbony. I mean, I'm pretty open about the name because, again, it's open sourced on GitHub and it's freely available for download. We build the plugins. It's supporting Java languages, Java and JVM languages at the moment. We're also building a similar solution for other languages as well. But today, this tool can be used in the IDE on the local. It also reports. Well, it also calculates the code coverage for the change and reports it into our Git system for peer reviewers and developers to see. It also reports, again, the same coverage into our rule engine that accounts for it during calculations of the risk of the release. Thanks to Sandbony, we realized that the brute force approach for testing is not an option any longer. Going from the change-based testing to predictive analytics in testing was pretty much a small step to make. So we put forward around 7 or 8 hypotheses where we were trying to determine or predict what would be the chance of a failure of the tests before actually running them. In other words, if you look at the test segment on the slide, and you'll see the greenish failure probability in test suite quality, this is where we are going to apply, or we are applying the predictive analytics. So it comes in 2 phases. One is we would like to, again, streamline our testing and test only what's worth testing. To do so, we put forward a number of the subset of hypotheses that basically is aimed on identifying high-value tests and prioritizing their execution in the pipeline. Our goal is to be able to run the most high-valued tests within the 30 minutes time frame of the execution. I think the biggest challenge for us is to determine what is this high value test is. Just because we capture all the test results that run in the pipeline, we have a full access to the test history. We decided to look into a few variables. What's the frequency of the tests failing? We discovered that there are a huge number of, as we call them, evergreen tests that never fail, not even once, during quite a long time of the execution. On a usual basis for the feature branches, meaning for development that doesn't, for the candidate, for the main code base, meaning, again, for the code and feature branches, we suggest not to run evergreen tests at all, just because they take a lot of time. We would want to run evergreens during the PR, meaning right before authorizing the merge, and obviously in the mainstream, in the main lines that are release candidates, such as the main branches or master branches or release branches. Another thing that we observed is that the tests have different, obviously, have different code coverage. I mean, the comprehensive tests have different code coverage. They also have different pattern of failures. Many of them fail once they are being introduced, and if they are fixed, they usually remain green. Something interesting was interesting to observe. We also discovered that some of the tests are very, very long running, and some of them simply don't have enough code coverage, meaning they don't penetrate the code base in the footprint, in the tangible footprint. So we took into consideration these variables. Again, the pattern of the test failures, the code coverage, the time it's been executed, the frequency of changes, meaning when was the last time the test was actually touched, was actually changed. And we fed all of these variables into our formulas, trying to calculate the usefulness or the value of the test. I have to admit that right now, probably the best trend that we see is the test failure. In other words, tests that fail more often are highly probable to find some problems, and hence we prioritize their execution. So within the 30 minutes time frame, we identify high value tests, B, prioritize them in the descending order of the value that we think it's worth, and execute those. That's our strategy for continuous integration, continuous delivery. Of course, we don't suggest not to run all the tests. We do run them periodically. We recommend them to run once in 24 hours on tangible size code bases, but those are more of regressions, or let's say resilience or penetration tests where we don't know yet how to prioritize those types of tests, meaning the non-functional testing is really hard for us to prioritize at this point. That actually brought additional benefits, that approach. It also drew attention of our developers to the quality of the test backs, where they started to realize that they carry all this baggage and they have thousands and thousands of tests, or even hundreds of tests that run for hours. We were talking about anywhere between an hour to 24 hours of test runs. And they started sifting through the testing packs, figuring which tests are old, they touch the functionality that's not being used, which tests never fail, which tests are way too fragile because obviously they depend on the system being available. And in addition to long-running tests, we also have a challenge of setting up the environments, because again, those are end-to-end or acceptance tests that require a lot of system dependencies to be in place before we actually even execute them. All right, thank you for the gentle reminder about the time. I'll move forward to the deployment. At the deployment phase, what we do in the context of the predictive analytics, we actually try to assess the risk of the change, the software change, based on our analysis of the test results. Yeah, you might say that it's not enough and we should look into production, and obviously everything that the only measure that we really need is to determine the breaks in production and failures. I'll be honest, today we don't have access to production. All that we have access to is tests, I mean, everything that happens before production. I'd love to assess the probability of a failure in prod instead of assessing the probability of a failure in test. But today, this is all we can do. One good thing, though, that we can assess the chance and the probability of failures of the tests before even going into the test phases. Again, saving a lot of time, not only executing tests, but also setting up the environments. All right, and during the deployment, basically the idea is to be able to link requirements and tests through the acceptance criteria, and to be able to make a judgment call. It's still a human judgment call about the test results. I'll proceed to the next slide, which talks about actually, so how do we do it? What is our predictive analytics platform and how it actually functions? We take input from quite a few data sources. Again, most of them or all of them right now are non-prod data. We know the outcomes of our builds. We know who committed when, against what issue, what files, what test files. All that information comes from CI/CD. We also know the peer reviewers, the code coverage, and so on. It also comes from CI/CD and source control. We have a number of solutions in our platform that run the tests integrated with the CI/CD, such as the performance testing, the UI testing, and so on. We call them test labs, and we capture results of those tests again in our system, as well as the code quality system. We also evaluate and capture the main results from there, such as the code coverage, passed, failed tests, and so on. We captured information about the security scans, and I'm only getting into the observability, production observability, getting data from production monitoring systems. That effectively gives us the data that I just described, and we can comfortably start asking and answering questions such as, what is the risk of our change, which is the overarching question we're trying to answer? How effective is our test suite? That we've made pretty tangible progress there. How fast we'll validate the change comes again from our analytical engine. What tech debt will occur? That's a multifaceted question that is not easy to answer. We have certain hypotheses put forward. We're experimenting with them. Looks like we've discovered certain trends that will be helpful to identify how much tech debt the change will occur. The danger zones of the software, that's pretty straightforward. The most flaky code, the code that fails most often due to testing or due to scanning, we capture that, we aggregate the results, we understand which parts of code failed, we understand who committed the code, we understand who reviewed the code, hence we can attend to that portion. And then how is the software being used? That's probably the most challenging question in my mind, because that implies instrumenting and observing the application live in production. But I also feel that this is the question that can bring us the largest benefit in terms of the software management and testing, if we can answer that. How we use the data? Well, we feed that data back into the developer tools. We would like to, in IDE, let's say, we would like to warn a developer that, hey, Anne, you are in the spot of the code base that has been changed by 10 developers for the past 30 days. And given your personal history in this code base, the history of the code base, the history of the build, the history of the tests, we predict that the chance of you introducing the error is about 75%. and obviously we don't want anyone to stop coding, and that's not the real prediction. It's more like a statistical analysis. The real prediction comes to play where we start giving suggestions that, hey, we think that you need to refactor the code, cover with more tests, retire your tests because they are inefficient, talk to Brian because Brian has committed the largest volume of the changes in this code base and he's the best to review your code. So something along those lines. The same information we feed into our peer reviewing system. The testing labs receive information about prioritization of tests that we need to execute. The risk and control analysis receives the information about our estimations of the risk, of the change risk. And effectively, we also improve our CI/CD cycles, as I described earlier, by change-based and efficiency-based testing. Why? What are the actions that we would like to take based on that data? Well, obviously, again, I would like to retire the unused functionality. And not only the main code base, but also the tests. Again, our problem is volumes, and we keep carrying the baggage that we accumulate across the years over and over and over again. Frankly speaking, our developers in general never come back and review the tests that they write. They just keep writing the same ones. So yes, we do have duplicate, we do have shallow, the same problems as everyone else. My goal is at least to reduce that baggage first. We'd like to, again, optimize testing cycles even more because, again, the volume and speed are critical. Predict the software change risk accurately. It's a multivariable problem that we need to solve. Predict the tech debt. We just made very first steps there. And the most interesting one is predicting the value, the business value of the change. I must say that in our firm, we put a lot of effort on validating the efficiency of the engineering, of the software engineering, meaning how well we code, how fast we commit and deploy. But what we don't calculate is actually the business value that our features, more like our activity, brings. That's still a black box. I believe that by applying a bunch of hypotheses and evaluating them, we'll be able to answer those. All right, I was reminded that we are almost out of time. I'll stop talking. The last thing I'd just like to switch to the last slide. If anything you want to take away, from this conversation, it's those 4 points that I have on a slide. I'm not going to read them out loud. I'm sure you can do so. Thank you. I hope it was not a stampede.
And thank you very much. If you don't mind stopping the share on your presentation. Thank you very much for that and giving us some insight into your processes there, and leaving us with that tantalizing prospect of looking deeper and deeper into this black box of how you're actually evaluating the business case for testing, which again I think is a core theme which we'll be coming back to time and again today and in future. I think that's probably the big trend for the next 5 years. I don't know if you agree. I mean, you mentioned static analysis, for example. Just one question here. How close are you to setting these enterprise-wide standards for an ROI from software testing? Are we talking about another 2-3 years? Do you have a program in place?
No, I think we are quite advanced. By the way, I do agree with what you said before. I think we're quite advanced in that area, and it's an awesome question that I actually wanted to cover and I forgot. I am actually very happy that we are moving away from setting hard targets, such as a certain percent of the code needs to be covered, or this many blockers need to be resolved. Rather than doing that, we are moving towards trending metrics, where we are saying, hey, your code base that you're about to release must be in better shape than what you currently have in production. So yes, we do have a program firm-wide scale. On the firm-wide scale, there are tons of metrics that we put forward, more than I can ever count, and a lot of people engaged in it.
Well, and we're finishing right on time. So I do thank you for that, as well as a fascinating presentation. Thank you very much indeed.
May I have half a second? I just want to mention that we hire in Glasgow and New York. Please reach out if you're interested.
Well, there you go. What a great opportunity. Thank you very much.
Thank you.